Hello everyone. So today we're going to be going over some simple integration concepts that are key to understanding more complex problems. So first we have this first problem. A ball is thrown vertically upward from a 6-foot tall tree. It reaches a maximum height of 52 feet. Given that a of t is equal to negative 32 feet per second due to gravity, what is its initial velocity? So we're going to be using the acceleration equation to find velocity and position, and then we're going to have to do a system of equations to find the initial velocity. So first, a of t is equal to negative 32. So v of t is equal to the integral of negative 32 dt. And remember to use t whenever we're doing these problems because that's the variable, not x, so keep them consistent. And we also can't forget our constant of integration. And s of t is equal to the integral of negative 32 t plus c1 times dt to negative 16 t squared plus c1 t plus c2. Okay, so we're given that the ball is thrown vertically upward from a 16-foot tall tree. So its initial height is 16 feet, so c2 is equal to 16. So we can substitute that in. And we're trying to solve for c1 here because that's going to be our initial velocity. So it reaches a maximum height of 52 feet. So we can use that to set our, so if it reaches a maximum height, that means the velocity is going to be equal to 0, right? So the time at which the velocity is equal to 0 can be represented by this equation if we rearrange the variables. So now t is equal to c1 over 32. And this is the time when the ball reaches its maximum height. So we can plug this into s of t, this equation over here, and then set that equal to 52 because that's what the maximum height is, and we can solve for c1. So negative 16 s132 c132 squared plus c1 times c1 over 32 plus 16 is equal to 52. So we can simplify this. Plus c1 squared over 32 is equal to 36. And then this cancels out to 64. And then we can make this a common denominator. We can add 2 here and then make this a 64. So we can add those two together. So c1 squared over 64 is equal to 36. So c1 squared is equal to 23804. Okay, and then the square root of that is equal to 48. So we get c1 equals 48, and that's going to be our initial velocity. So our initial velocity is 48 feet per second. Remember your units. Okay, so for our next problem, we're going to be doing a right Riemann sum estimate. So it says use a table below to estimate the definite integral from 2 to 8 of f of x using the right Riemann sum with 6 subintervals. So first step is to find our delta x, so like the length of our subintervals. So in this case, since we have it goes from 2 to 8 and we need 6 subintervals, it would each be of 1 unit. So when we write it out, a of m, and also because the Riemann sum is an estimate, so we have to use the approximation, and then it would be 1 because that'd be the length of the subunit, times, and because it's a right Riemann sum, we're going to start from the rightmost value and then keep moving by 1 unit. So it would be f of 8 plus f of 7 plus f of 6 plus f of 5. I'm going to write it below because there's no much room. So we're going to stop at f of 3 because there's nothing to the right of 2. So 3 is going to be our last value. So now we can just substitute all the values in to calculate the sum. F of 8 is going to be 15 plus 11.25 plus 8 plus 5.25 plus 3. And if you put this into your calculator, you're going to get 43.75. And that's going to be our right Riemann sum for this question. Okay, so for our last question, we have a limit process. So it's asking us to find the area of the region between the graph of the function and the x-axis over the given interval. So first, we're going to be finding delta x. And the formula for that is b over minus a over n. In this case, the b value is 8 and a is 2. So it'd be equal to 6 over n. And then we have to find ci. So this represents the width, and this would represent the height. And the formula for the height would be a plus, or well, this would represent the x value for the height, because we're gonna end up plugging it into the function. So it'd be a plus I times delta x, which is 2 plus 6i over n. So now we can start the computations. Remember to carry out your limit notation and summation notation throughout the entire problem. 2 plus. So we're going to plug this value into f and then multiply that by our delta x value. And now we're going to have to substitute that into the function. So it's 1/4 2 plus 6i over n squared minus 1 times 6n. Okay, now we just have to continue simplifying this while we're still carrying our notation through. So we're going to distribute here, and we get 3 over 2n times 4 plus 36 squared over n squared plus 2ab, so that'd be 24i over n minus 6n. Okay, and then we can distribute from here again. So remember to keep simplifying along the way so you don't have to worry about you having too many big numbers in the end. So here, when you multiply this out, you get 6 over n. And then 54 I squared over n cubed. And then here you can cancel out the 2 and 12, so you get 36 I over n, And then remember, you have this minus 6n over here, which actually cancels out in this case with this 6n over here. So then we can split up our summation notation here, and we get n equals 54 squared over n cubed. We split it up. Oh, I forgot a squared here. Yeah, just be careful when you guys are solving these. Okay, and then we're going to use the formulas for simplifying the summations. So for I squared, when we have I squared, we're going to use n times n plus 1 times 2n plus 1 over 6. And when we have I, this formula is n times n plus 1 over 2. So we can plug that in. And in this case, we have to keep the 54 over n to the power of 3 because that's like our coefficient. So we have to keep that in when we're multiplying it. Over 6. And once again, we can like still simplify along the way. So we don't have to worry about too many large fractions or numbers in the end. This cancels out to 9, and this becomes a square. So this, and we can distribute that 9 as well. So we get 9 n plus 9 times 2n plus 1 over n squared. And then here we can cancel out the 2 and the n, and we can also distribute that as well. 18n plus 18 over n. And then we can continue simplifying. For this first one, it would be 18n squared plus 27n plus 9 over n squared. And this one would just be plus 18, because here as n approaches infinity, it approaches 18. And now we can do it for the first one too. So in this case, this first term also approaches 18 using our rules. So we get 36 as our answer. So that was the area of the region, this region of the graph. So when I created these problems for the second one, I made it the same function. So all of these values are coming from this function. So just to compare the right Riemann sum with the limit process, which is more exact because n is technically like infinity, approaching infinity, as opposed to like being 1 or 6 in this case, but because we have 6 subintervals. So the right Riemann sum was, or sorry, the right Riemann sum, yeah, was 43.75, and the limit process we got 36. So in this case, when the function is increasing, we found that the right Riemann sum overestimates, because if you think about it, if this function looks like this, right, because it's a positive quadratic, if we're estimating to the right, then we're going to overestimate most of the values, like this. Like this shaded region is all the overestimation. So the right Riemann sum overestimates when it's increasing, and And the left Riemann sum, when it's increasing, would be an underestimation, because it's always going to be under the graph in this case. So yeah, that's about it. I hope you enjoyed this video and it was helpful. Thank you for watching.